All right. Here we go. Ladder and sphere problems. Okay, these are not actually correlated with each other, but they just seem to work well with each other. That's why I put them. These aren't like the shadow and the cone problems where what we did on the shadow one was a skill you needed for the other. But these are also important to know because they could come up, especially the sphere ones. Alright, so here we go. A ladder 10 feet long rests against the vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from it? So let's draw a picture, okay? So we have a wall, right? And we have a ladder leaning against it. How long is the ladder? 10. Is the length of the ladder ever going to change? No, okay, so remember that that's constant. Okay, what will we label this? Y and this? X, just to correlate with the axis. What are we trying to find? How fast is the top of the ladder sliding down? So we're looking for dy dt. Should that be a positive number or a negative number?
Negative.
Negative. Why negative? Because it's sliding down, so that distance is decreasing, right? Okay, at some rate. Find when?
Bottom of the ladder.
When the bottom of the ladder is 6 feet from the wall, so what represents that? X. X equals 6 feet. Given. What are they giving me? The rate at which it's falling? No, that's what we're looking for. The rate at which they're what? Pulling it, right? So that would be d what? dx dt equals 1 foot per second. Okay? So far so good? What's the equation that I'm going to need in order to work all that out? Pythagorean theorem? Okay, so what's Pythagorean theorem? X squared plus y squared equals 10 squared. Why can I put that 10 right now? Because it's never going to change, it's constant, right? So remember, things that are constant throughout the entire problem, never ever changing, you can replace at this point. Anything else, you have to wait until after you differentiate. Okay? So let's do it. Get the derivative. Quick, quick, quick! 2x dx dt plus 2y dy dt equals? Do I have everything that I need? Do I know x? 6. Do I know dx dt? 1. Do I know y? Uh-oh. I don't know dy dt, but that's what I'm looking for. So can we find y? Very good. So need to know y, right? When x equals what? 6. So when you don't know y, you solve for it, right? By plugging that in. Huh? Didn't we do these? Yeah, we did stuff like this. So this will be 6 squared plus what? Y squared equals 10 squared. So this is actually y equals 10 squared minus 6 squared, and we want the square root of that, right?
8.
So that's 100 minus 36 at 64. Square root of 64 is? 8. You guys are beasts. You did this yesterday? On one of them? It's the same one? We've done some like these? Awesome. So you're going to practice some more. Okay? So now we can plug in. So 2 times what? What's x? Times dx dt plus 2 times what's y? Times dy equals 0. So 2 times 6 is what? 12. We're going to minus the 12, right? And 8 times 2 is what? 16. And we're going to divide by the 16. So can I jump straight to what it is? Or do I need to show the steps? dy dt is equal to negative what? 12 divided by 16, which reduces to what?
Negative 3/4.
Negative 3 over 4 feet per second. dy. Kindergarten stuff? Do I need to do any more examples, or that was enough for the ladder problem?
So the last one,
Huh?
I think that's enough for that one.
That's enough for that one? Maybe we should do one more,
Yeah, okay.
just to be
yeah.
safe.
There's only two.
I mean, there's only four examples,
Never
right?
mind, do it.
I mean, how long could it take us to do, right?
10 minutes. Like the whole rest of the afternoon.
Like I said,
That's
your
pretty
question.
fast. We did the first one pretty fast.
Yeah, but this is like the second one.
This one's super
Huh?
hard.
We're gonna have to show more steps.
Yeah, let's try it.
Yeah.
So a ladder 50 feet long is being pushed against the wall at a rate of 5 feet per second. Ooh, so now what are they doing to the ladder? So now they're what? Pushing the ladder, right? So now what's increasing?
The height.
The height of the ladder, but what's decreasing now? The distance from the wall, right? Okay, so be careful, right? When the bottom of the ladder is 30 feet, what is the top of the ladder doing? So what is that asking for? They want to know what is the top of the ladder doing.
Moving up.
It's increasing, right? But I want to know like specifically. So we were looking for what? Let's draw the picture, right? So the ladder is 50 feet long, right? And this will be X and this will be Y. So we want to know what the top of the ladder is doing, so we're talking about Y. How Y is changing. When the ladder is 30 feet from the wall, so X equals 30 feet, given the ladder is being pushed, dx dt equals 5 feet per second. Yeah? Should it be negative, Caitlin? You're asking? It is negative, very good. Thank you for noticing that, nobody else did. So why is it negative? Because I'm pushing it, so what's happening to this distance? It's decreasing at this rate. Okay, so is he pushing it pretty fast? Yeah, because he pushed it pretty hard for it to move 5 feet in 1 second, right? Boom!
Is there someone up there?
There's someone up there, something's gonna happen to them, right?
Die.
I mean, it's a pretty long ladder, it's 50 feet ladder, so.
It's already 50 feet in the air, he's like,
Okay.
You're falling for the longest time.
He's not 50 feet up, but,
I
right?
mean, what if he's at the
Yeah, what
bottom?
if, no, but what is he,
He's
what
like
if he's at the
20
top?
feet
It
up.
doesn't say.
There has to be some angle, right?
What if
He's
he's
not
at the
completely,
top?
if this was straight, then he would be 50 feet up. But anyway, I get your point. What would my equation be here? X squared plus y squared equals 50 squared. And again, we can put the 50 because it's what? A constant, very good. Okay. So differentiated, quick, 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 quick.
2x dx dt
Plus
2y dy
equals? Do we have everything we need? Oh, what are we missing? Y, so we gotta find y, right?
y
Find y, so we know that it's what? 30 squared plus y squared equals 50 squared, so can we jump straight to tell me what y is?
yes
What is it?
40
40. How do I know it's 40 right away?
it's the identity.
3, 4, 5.
3, 4, 5. It's a Pythagorean triple. All they do is
Triple.
multiply them by what? By 10, okay? So we're good. It is 40. So let's jump straight back over here. So 2 times what?
30
30 times
negative 5
-5 plus 2 times 40 dy dt equals 0. Okay, so what's 30 times, oh, let's do 2 times 10 first. That's what? Negative 10 times
2
30.
times 10
Negative 300.
I mean 2 times negative 5, right? Negative 10 times 3, 30?
Negative 300.
Negative 300, right? And when I move it over, it becomes what? Positive 300. And then we're going to divide it by what?
80
By 80. So dy dt is equal to 300 over 80. The zeros cancel out. Can we reduce 30 over 8? What would that be?
Yeah.
Like
15 over 4. And what would the units be? 3%. So más o menos as a decimal, what would it be? How many 4s go into 15? 3, so 3 point something? So he pushes it at 5 feet per second, but the ladder's only going up at a rate of what?
3
3
and
point
3
something
quarters.
feet per second. Okay? Cool? Alright, let's look at part B. Part B says, at what rate is the area of the triangle of the ladder, enclosed by the ladder, the wall, and the floor changing? Okay, so they're looking for that area of that shape, enclosed by the three things. How is that area changing? Is that area increasing or decreasing?
It's decreasing.
It's decreasing? Yeah, because imagine if it were to go all the way, would it have any area?
Yes.
Yes?
No.
That would be 0, right? So it is decreasing. Okay? So that means that my answer better be what? Negative. Alright, so let's see, what are we trying to find? dA dt. I'm not going to write all the things because they're all going to be the same from the one we just did up there. So let's just jump straight from F to E. What's the equation we need here? Area of a triangle. What's the area of a triangle? 1/2 base times height. In this case, x times what? Y. And let's differentiate it. So to get the derivative, we have to use what? Product. Let's do it. dA dt equals derivative of the first. Half dx dt times y plus half x dy dt. Calm down, like if it was hard. Okay, so now let's plug in what we know. So we got half times dx dt. What was dx dt? -5 times y. What was y? 40 plus 1/2 times x. 30 times 15/4. Okay, let's try to make this easy for ourselves. So if we can divide the 40 by 2, right? That gives us what? 20, and then 20 times 5? -100. Okay, we can divide the 30 by 2, that gives us what? 15, 15 times 15? 225/4, not 30, we're not adding.
Sorry.
It's okay. So now in order to combine these, we need a common denominator, right? So over 1, so we can multiply by 4. Right? So we have 400 minus 225, what is that going to end up being? -175 over 4. And that would be what units?
Feet per second squared.
Feet squared
Feet squared.
per second. Okay? Why feet squared?
Because only the foot is being squared.
Because it's area, right? Okay. If we were to include our units next to the numbers, you would see that we would end up with feet squared over something. I just didn't include it. I didn't want to do that stoichiometry, is that what it's called?
Oh my
Remember
god. Stoichiometry.
Stoichiometry, where you're like working with the units and canceling them all out? That was so much fun.
I love Miss
Where did you
Levine,
do that, in chemistry?
Yeah, in chemistry.
I had a son that it was not good.
Yeah? I heard it was really good.
No, it wasn't.
The chemistry or whatever.
Don't be roasting teachers, okay? We're recording.
Mr. Birch, dude.
Mr. Birch?
We would just watch Mythbusters videos.
What?
That was really hard.
Wow. Okay, so we're good with ladder problems? We got it? Any ladder problem I give you, you can take care of it? Okay, usually the cone problems are the ones that give us a little bit of trouble. And the shadow, but you can work through them and then you'll get through. Let's look at the sphere ones, okay? The first one, we're gonna kind of work it out the long way, and then the second one, we're gonna discover why we did it the long way in the first one, and then hopefully use the shortcut for the second. Cool? And it's not really that long, because I didn't give you too much space, right? Okay? So don't get crazy. So we got a spherical balloon, and it's being filled with air in such a way that the radius is increasing at a rate of 2 centimeters per second. At what rate is the volume of the balloon changing at the instant when the surface area, where the surface has an area of 4 pi square centimeters. Okay, so what are we trying to find according to this problem? The rate of change of the volume, so that's d, v, dt. When are we trying to find that? So when s equals 4 pi,
Please excuse this interruption. Teachers, please do not allow students out of class without a pass, and only one student per pass. Thank you.
Well, that's the sophomore.
I don't know what's going on. So s will equal what? 4 pi centimeters squared, and s stands for the surface area, okay? Given, what are we given? dr dt? Very good, they're telling us the radius is increasing at this rate. So dr dt is equal to what? 2 centimeters per second. Does everything match? The units? Something we've been taking for granted, but in some problems, like maybe the homework of this one, they won't match,
Right idea.
okay? Or maybe the homework of the next one, I don't remember.
I would
I
have.
think it's this one. Okay? Alright, so what equation do we have to use here? Volume of a what? Sphere. How do we find the volume of a sphere, Ashley?
I got you.